Smart contract in Solidity. As I've told you earlier about the smart contracts and all, smart contract provides a layer of computational logic that can be executed on the blockchain. So basically, business logics and computational logics all mixed up becomes a smart contract which is executed on the blockchain. And we'll get all the features of it. Okay, let's talk about Solidity. Solidity is a programming language. You have object-oriented programming language. In this, we have contract-oriented programming language. To be more specific, it is basically a high-level language, which is a combination of Java, JavaScript, C++, and all such stuff. It is specially designed to write smart contracts and to target the Ethereum virtual machines. It gives support test environments like the Remix, which is an excellent test environment. We'll be coding on Remix only, which is platform independent. You can easily code on it online. So next up, we have structures of smart contract in Solidity. How should we structure the smart contracts to get the most out of it? So firstly, we'll start with the data or state variables. So firstly, you will have a pre-compiler line, which is the pragma solidity. Like that, you will have a line, which is a pre-compiler line. And then you have the contract and the contract name. And then the contract starts. Then you will have some data or state variables. So you might have a uint, you might have an address, you might have a string, like that. Then the list of functions. How should the functions go? First, you should always bring the constructor, as it is the first function to be called. Then a fallback function. A fallback function is basically the one which takes money into the smart contract. Then we have view functions, pure functions, public functions, private, internal, external, all such stuff. We'll discuss everything in our lab class. Then user defined data types, like basically the structs and enums are user defined data types, which mostly comes after some functions, but you can also put it at the top. Then we have modifiers. Modifiers is basically a precondition check which helps us check the condition, and we put it on the user input to check the user input conditions. Next up, we have events. Events are basically used for triggering some outside, like the outside applications, where it cannot directly, like the blockchain cannot directly give out information that okay, this has changed, the state has changed. For that we have events. So events tell the client side applications that some change has been done. Next, how the processing and deploying is done. Basically, smart contracts firstly needs an address to get deployed and invoke its function. There will be an address. You check out any smart contract, it will have an address on which at which it is deployed. Then the address is basically computed by the hashing and the account and the nouns. That is a lot more thing we'll discuss later. Then ABI generated for high level applications. ABI is basically application binary interface, which is generated for high level applications. ABI can be defined as the interface schema for a transaction to invoke functions on the smart contract. Then the EVM provides execution environment for smart contract bytecode. So that was it for the theory part, and now we'll be moving straight into the practical part.